So today's video is going to be a little bit weird, a little bit different. I'm going to be ranking the elements by which ones are my personal favorites and which ones I just personally have something against. I guess with that, let's get into it. So I'm going to go in reverse order and start off with 118. Yeah, I'm doing all the elements on this one. So my least favorite element, Moscovium. Why? Well, when I did my element randomizer, it was the last one to come up. And also it's one of those really unstable elements that require creation in a lab, so it will come as no surprise that the next ones in order from least favorite to most favorite are Berkelium, I hate these names, Einsteinium, Livermorium, Nihonium, Lawrencium, Californium, Rutherfordium, Darmstadtium, Seborgium, Mendelevium, Nobelium, Neptunium, Roentgenium? Another one I have trouble pronouncing, Mednerum, Dubnium, Flavorium, and Fermium. So that is from 118 to 101, my least favorite elements. Now, what's directly above it? My 100th favorite element. In other words, it is way at the bottom of the list. Thallium. Yes, it has my initials, but it's also extremely toxic, difficult to work with. A bit like me, actually. Anyway, the next one, 99 on my list, radium. Extremely radioactive. Extremely radioactive, alkaline earth. Let's see, the one above radium is cadmium. I don't know what made me think that cadmium is slightly more redeemable than thallium. But cadmium is pretty much equally toxic. It's really bad. Can't remember if it's that one or thallium that's the suspected carcinogen because it kills people too quickly. I think it's thallium. Let's see, right above cadmium is barium. No good reason for that one, it's just not really common, and for some reason, just saying the name gives me heartburn. And above that is protactinium. Huh, where do I put it there? Oh, right, no, it's not protactinium, it's promethium. Why don't I like promethium? Well, it's because it's the only radioactive lanthanide. It just has to ruin the series. Anyway, above that is lutetium. For similar reasons, it just kinda sits there and ruins the lanthanide series for me. Above that is borium. Not entirely sure what made me decide to put it there, but yeah, it is what it is. Above that is hassium. And above that is technetium. And what I can tell about technetium is that it's oddly placed. I mean, it's, obviously in order, but it's also, extremely radioactive, which is strange for where it's at. It's in the middle of the transition metals, and it's actually pretty high up. I think it's, in the second row of the transition metals, so it's kind of a weird one, but hey, I mean, it's also a little bit cool. Arsenic. Next one is polonium. No particular reason, just that it's extremely radioactive and right next to bismuth, so it's a little bit more redeemable than most radioactive elements. Let's see, polonium tennessine, or tennessine. That one just kind of annoys me. And above that one, we have my favorite halogen, actually technically my least favorite, fluorine. Burns everything. So I don't really like it. It's really reactive. Let's see. Above that, lead. It's really common, really toxic, and just kind of overrated in general, in my opinion. Above lead, we got plutonium. Yeah, it's gotta be made in a lab. It's just one of those things I just never want to get mixed up in, you know. Above that, we got copernicium. Mainly just because it pretends to be copper in name only. Americium. I actually put it a little bit higher because I actually kind of like it. It's in our smoke detectors, I think. I don't know if they've used something different, but last I checked, it's in our smoke detectors, so it's kind of nice. You know, saves our lives and all that good stuff. Above that, oganesson. 82, protactinium. Yeah, there we go. And that's because it's just kind of weird. I think that's an actinide. Let me check. Yes, it is an actinide between thorium and uranium. Always messes me up whenever I try and redo the periodic table. Try and recreate it. See, above that we have actinium. I'm only putting it so high because it's the beginning of the actinide series, so yeah, there you go. Above actinium we have radon. Radioactive gas. Barely ever exists, and, well, it's a noble gas, so I gotta rate it a little bit higher. Above that we have chlorine. Yeah, chlorine is just... it just sticks to everything, and I don't like it. Yeah, it messes up. It messes up so much, but then again, it is kind of necessary. Our stomachs are filled with hydrochloric acid, so yeah, it's kind of necessary. Also, it does help with isolating elements. Alright, above chlorine I have astatine. Why? Because it's also a halogen, and it's radioactive, really radioactive, and it barely exists as well. But it's still better than chlorine. Above astatine we got oxygen, for the same reasons that I don't like chlorine. But oxygen is slightly better because, well, we kind of breathe it in order to live. Too much of it, though, you can actually get oxygen poisoning. Kind of a weird thing, but it happens. It happens. Above that is francium, which finishes off tier 2. I don't think I mentioned the end of tier 1, which was fermium the first time. But tier 1 is please no. Tier 2 is the bane of my existence. And yeah, francium starts that one off because it is yeah. It is an alkaline metal. But it's also really radioactive, and I'm not sure it can actually exist without synthesis. I could be wrong though. Let's see, above that, and into tier 3, we have annoying but not bad, bromine. Just because it's a liquid halogen, and I find that to be really cool. Above that, we have praseodymium. I think I got that right. Only because of its really weird name, I've decided to put it here. And above that we have hafnium, oddly enough, named after the capital of Denmark, the Latin name for it anyway. Above that, curium. I don't know why, just stuck it there. Above that we have hydrogen. I don't know why I put hydrogen so low, but just don't really like it that much. Thorium. Thorium's actually pretty cool. I think thorium is a really good actinide. Of all the actinides, it's almost my favorite. But the one above it is uranium because, well, everybody loves uranium. Above that we have dysprosium, which is a lanthanide. If you watch Cody's lab, it's actually in a few of the intros to his videos. He has a bunch of different elements that spell out the name of the channel, dysprosium being one of them. So, cool stuff, you know? Cool stuff. Neon is above that at 67. Above neon, I'm putting krypton at 66 because Superman. Above that, I'm putting argon and then xenon at 64. And then helium at 63 because that's also a noble gas. But helium is the most useful, most widely used, most well known. Although we are running out of it, so be careful, y'all. Above helium, I'm putting gallium because it destroys aluminum. As much as I don't like aluminum, come on, gallium, why you gotta do that? 61, beryllium. Why? Because it's like lithium. It's just one element over. It's over in the alkaline earth group. But it's also not a particularly great one to work with, so I haven't worked with it yet, for obvious reasons. Yttrium above beryllium. I don't know why I put it there, frankly. Same with scandium, which is right above yttrium. Maybe it's above... Are those two in order? Yes, they are in order. Yttrium, scandium in the periodic table. Love it. Above that we have iodine. Weird though, I put a halogen at 58. That's oddly high. I'm putting iodine at 58 because it is a solid halogen at standard temperature and pressure. Same with, you know, the liquidity of bromine. You can freeze bromine, and you can turn it into a gas. But, you know, standard temperature and pressure. It's a liquid. Anyway, above that, we have phosphorus. It's got 4 allotropes. I mean, it's pretty cool, but at the same time, it is phosphorus, and white phosphorus is scary in my opinion, so I don't work with it. Also, it's pretty difficult to procure, so yeah. Above that, we've got sulfur. Don't know why I put it at 56. Seems a little bit low for an element that burns blue. Like, nice deep blue, but eh. No, it's probably because it's one of those huge constituent elements that you find in those ores, or one of those elements you find in those ores that just kind of is there. It causes us to have to extract pure elements. Above sulfur, I'm putting erbium. No particular reasons, just a lanthanide, but it's got a strange name, so just gonna put it down there somewhere. Above that, we've got mercury, the liquid metal, also the very toxic metal. For that, we'll just look up methyl mercury or dimethyl mercury, which is even worse. Keyword in that being di. Anyway, above mercury, I'm putting rhenium and then rhodium. No particular reason, although they're both refractory metals, and as much as they're useful, I can't really melt them down, can I? Above that, and I guess technically beginning tier 3, because I'm going in reverse order, I'm putting nitrogen, which is at 51. Above nitrogen, I have strontium, which I believe is an alkaline earth element that is right below calcium. Yes! Right next to rubidium. Alright, and above strontium we have iridium, which is extremely rare on Earth, but less rare in space. Weird one there. Above iridium, osmium, the densest element. I actually kind of like osmium, it's just kind of one of those legends in the periodic table. See, above osmium, ruthenium, which is right below iron. From what I understand, it doesn't like to corrode, so there you have that. Selenium above ruthenium at 46. I believe selenium's the one with 2 allotropes, one that's gray, one that's red. Pretty interesting, pretty cool. Above selenium, we have tellurium, because I believe they're in that order in the periodic table. Oh no, they're in reverse order, actually. Let's see. Why did I put tellurium above it? Right, because it makes copper less corrosion prone. It makes it more corrosion resistant. So I do kind of like it, you know? Above that, I got terbium. I think it's probably got one of those more achievable melting points, if I can remember correctly. I think that might be why I put it there. We'll see. Thulium at 43. not to be confused with thallium, thulium. See, above that we got tantalum. I'm only rating that one so low because it's one of those conflict-causing metals. In fact, it's probably one of the most famous ones to cause conflicts. Above that we've got europium. Wow, why did I put one with such a weird name up there? Maybe it's easier to melt. Above that at number 40 we have ytterbium. It's got a cool name. I believe that's YT. Yes, it is a lanthanide, so there you go. Holmium, number 39. Man, why did I put holmium there? Lost on me. Boron at 38. It's used in lock shackles. It's pretty good. Generally speaking, a pretty strong element. It's in the boron group. Above boron, we have germanium. Not bad, not bad. It is a semi-metal, much like silicon. In fact, it is right below silicon. Above germanium at 36, we have niobium, which is the beginning of tier 4. What I have titled neutral interests. I don't necessarily have much of an opinion on these. They're just kind of interesting. So, everything from niobium to strontium, neutral interests. Now we're getting into the stuff I like. Number 35, molybdenum. Oh, it's got kind of a cool name. It's also a refractory metal, and yeah, I mean, it's pretty cool. I think they might use it in some forms of steel, too. Not sure. Above that, we have 34, tungsten. I like tungsten. I have a tungsten carbide ring, and that's why I like tungsten. It's one of the first weird metals that I really was able to identify. Yeah, it's pretty cool. Let's see, above tungsten we have 33, palladium. It's kind of a weird one. It's in the platinum group, which, I mean, the next one is platinum at 32. Unfortunately, all these precious metals are really expensive, so they're kind of, rated a little bit lower, but I don't know, palladium and platinum are pretty cool. I believe they're both used in catalytic converters, so the more you know. Don't go stealing those now. Gold at 31. Gold is corrosion resistant, extremely corrosion resistant, just like platinum and palladium. A little bit more common, I think, but it's also really expensive because everybody wants it. Number 30, zirconium. Right, those are used to make fake diamonds. Yeah, zirconium's pretty cool. Okay, above zirconium we have gadolinium. Oh, yeah, that one's a cool one. It's in the lanthanide series, and I believe I'm actually able to melt it down with the temperatures I can achieve, so not that bad. After that, we have silver. Again, a bit more of a precious metal. It tends to run a little bit higher, but silver's actually pretty cool. I like it. In fact, so non-prohibitively expensive, I have a ring made out of it. Sterling silver, so it's actually silver alloy, but silver's pretty cool. I like it. I also have like 4 silver cups I plan on either selling or melting down. Probably going to melt down into a bunch of rings and immediately increase the value. Let's see. Above that, we have indium. Man, why did I put indium over silver? Because it's weird and in the boron group, and I like the boron group, kind of. Yeah, you're gonna see a weird contradiction come up later. So, indium's pretty cool though. It's a really soft metal. It's one of those ones I wouldn't put in an alloy, but definitely nice to have on hand just cause. It's just cool. Let's see. Vanadium at 26. Weird spot for refractory metal. Tier 6, also called Greatness Achieved. These are some of the elements that I just really like. Not necessarily legends, but I just like these ones. So at 25 we have titanium. It's light. I keep forgetting that it even exists, but when I do remember it, It's actually pretty cool, and it's one of those things that's prohibitively hot, so I can't really work it that well, but, you know, it's still pretty cool. Still pretty cool. Useful. And if I could forge it, I would. In fact, I think there are ways of doing that. It's just, I wouldn't recommend it, because I understand titanium can be a little bit explosive, so caution. Next we have rubidium. I like rubidium. Actually, I just like all of the alkaline metals. I believe. Let's see, 1, 2. Did I already go over cesium? Oh, no, cesium's actually next. Right there. Because I like cesium a little bit more than I like rubidium. Just because it's more reactive. I know, contradiction in terms. But I like alkaline stuff better than, you know, halogen type stuff. So, you know, you can't throw a halogen in water and be like, ooh, explosion. You throw a halogen in water and it's like, ooh, it's acidic now. Or something like that, I don't know. I think that's how they make hydrochloric acid. Above cesium we have 22 chromium. Should have rated that one lower really. Although it is part of stainless steel, and I do like the properties of stainless steel. Specifically the stainless part. Cobalt at 21. Cobalt's a really cool one. Just because, you know, it's, again, in some steels, it's one that we don't generally think about a whole lot. In fact, I keep forgetting it even exists. I think it also burns blue, so fun stuff, you know. Above cobalt, I put samarium. I think I want to work with samarium in the near future. It is a lanthanide. And I'm thinking I actually really want to work with this one. I think I might actually get some of it pretty soon, and I think probably melt it into something, or better yet, I think I'm actually going to use it for a different experiment. Don't know if it's going to work. I think I'm going to try and make a eutectic mixture of salts with it. Real fun stuff, real cool stuff. And I, so far, pretty much have the means to do it, too. That's the crazy part, so here's for hoping anyway. Above that we have lanthanum. The lanthanide namesake, so I like lanthanum. Above that we have neodymium. Slightly more common, in fact, is probably the one lanthanide that everybody's probably heard about at some point in their life, in the form of a neodymium magnet. Calcium coming in at number 17, just because it is that thing that's just so tantalizingly close, but so far away because of oxygen and chlorine. But yeah, no, calcium, again, it's a little like lanthanum. I want to hold up a piece of bronze and be like, this has calcium in it. And it isn't chalky either, it's just straight up calcium metal. See, above calcium we have cerium. Right! Now I know why I rated cerium so high. It's because it's got the same namesake as a town that I live nearby, so yeah, I'm definitely going to rate that one pretty high, coming in at number 16. Obscenely high for a lanthanide. Next we have magnesium, and you may be wondering why I'm facing this way and not this way. It's because I messed up on the original recording at this spot. I had something else here instead, so right here we have magnesium. Next, I have sort of one of my pet peeve-ish elements, but also one that I have that's a little bit weird, but it's also kind of common. Manganese. I know some people probably haven't heard of it, but it is in a lot of steels and such, so you probably encounter it on a daily basis and don't even know it. Above manganese at 13 we have potassium. I like alkaline metals, and potassium's really cool. I mean, it's in bananas. Potassium 40 makes bananas a little bit radioactive, about 5 times as radioactive as sleeping next to a person for 8 hours. Which gives you a dose of radiation. very, 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 very small dose of radiation. Bananas give you 5 times that. Also, a very, 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 very small dose of radiation. Above potassium, we have... I just can't get over that radioactive bananas thing. Anyway, above potassium, we have sodium at number 12. I like sodium. I'm unapologetic about that. Tin, number 11. Why? I don't really work with it, but it is in a few bronzes, and, well, yeah, I mean, tin's pretty cool. It's got 2 allotropes. You got your regular metallic tin allotrope, and then you have this weird one that acts a lot more like a ceramic. Above that, we have number 10, bismuth. Bismuth is a pretty cool metal. I mean, it's a lot like lead, just not toxic. You get like 8 pounds of it for like 64 bucks. It's nuts. Anyway, zinc at number 9. I don't really like zinc because it oxidizes way too easily whenever I melt stuff, but it's also pretty common. Like, I have a lot of zinc, and you have a lot of zinc too. A lot of zinc in pennies. So, yeah, pennies are actually mostly zinc, like 97% zinc. Just plated in copper because we want to make them look valuable, and are really not. Anyway, speaking of stuff having to do with copper, nickel at number 8. Just because of its alloying with copper, I gotta put it up there. I've worked with it a few times. I don't know if I've put the video out for this, but made an alloy. Just gonna kind of... There we go. Made an alloy that has nickel in it. Y'all are gonna see that video if you haven't already. If it's out already, I'm gonna try and put it up there once I release it. I don't know. Well, is it gonna be up there or is it gonna be up there? I don't know. It's one of those card things that comes across, so we'll see. But yeah, I mean, nickel's pretty cool. Okay, so in the last 7, we've got carbon. Carbon's a pretty good element. We need it to live. It is the main component of organic chemistry. After that, we have iron. Iron's pretty necessary to what I do. I really like iron. Yeah, I hammer out iron railroad spikes. It is the main component of steel, so yeah, I really like iron. It's malleable, ductile. It's the best metal for blacksmithing that I've ever encountered, so sorry, other elements. Iron's pretty great. Otherwise, I'd actually probably rank it pretty low, but because it's so common and because it's so easy to use, I'm rating it this high. Above iron, we have aluminum. Because aluminum, despite the fact that it's just a really terrible metal, is just so commonly used and so widely used, and it's so available to me that I kind of like it. It's easy to melt down, and despite all the crap I give it, it's actually not that bad, so aluminum is a nice, solid, adequate metal that's easy to melt down, and nice like that. Above aluminum, we have my second favorite metalloid, antimony. Yeah, it's actually kind of weird that I put it up here, but I really do like antimony. It's just so cool. I love it. It's used in lead alloys. You'll just find it in the weirdest places. It's a very specialty use element, but I still like antimony just because it's antimony. It's even got a really cool name in my opinion, even though I think I pronounce it wrong. And now we have arrived at tier 8. We dine in Valhalla. Okay, maybe a little bit dramatic, but to start us off, we've got copper coming in at number 3. Copper's easier to melt than iron. It's orange in its natural state. We're not talking oxidized, we're talking straight up copper is orange. Does it get any better than that? I mean, well, other than gold and cesium, but I mean, does it get any better than that though? It's just such a great little element that's got its own nice reflective sort of thing going to it, so I don't know, I like it. And it's the main component in bronze. I can melt it down. I like melting down bronze, so yeah, fun to alloy with. Number 2. Silicon. Yes, I had quite a few episodes devoted to trying to isolate silicon because it's everywhere. You just don't see it because it's in sand, it's in our electronics, it's everywhere. It's used as a semiconductor. Without it, we would not have modern technology. And I also just kind of want to put it in a few alloys just to, again, mess with the world and be like, this piece of bronze has silicon in it, or this piece of steel has silicon in it. And just have something really fun and cool to mess around with. But I digress. At number 1, my number 1 all-time favorite element. This will come as no surprise to anyone who knows me. Lithium. Lithium is my favorite element. It is the lightest metal. It is number 3 on the periodic table, but it's just so cool. It's a really light metal. It's used in batteries. You can pretty much just cut it with a knife, if I'm not mistaken. It's a really, really soft metal. It's a really, really light metal. It is pretty reactive, but just because of its weirdness and just because it's that nice little metal sitting up there by itself, well, next to beryllium, but sitting up there right by itself, I just gotta say, I love lithium. And also, it burns this nice purple color. With that, we have completed the elements, all 118 of them in order, all the way from moscovium to lithium, in the order in which I like them, so remember, just keep in mind, this is a completely subjective list. There are no scientific reasons why I like any of these metals more than any others. It's just personal preference and my reaction to them when I see them on the periodic table, so yeah. I could have just as easily put any of these in any other order, and it would have been just as valid, so I encourage y'all to think of your own projections and your own lists and see what you come up with. So, anyway, I encourage you all to form your own informed opinions on this. Hopefully not base it off of my own. Anyway, hope you guys enjoyed the video. If you did, please do like and subscribe. I put out content like this, but also some other content that is markedly different from this, so if you're watching this and you're a loyal viewer of mine, I apologize for this one. Oh boy. Anyway, thank you guys for joining me for this video. I hope you all enjoyed it, and I hope you all have a wonderful day.